Lesson 68 is essentially a review of even and odd functions. So, I don't know what you guys remember from pre-cal about even and odd functions. If you happen to remember anything.
It sounds familiar. I'm sure I would get it if we talked about it.
Once I start talking about it, I'll come back to you. Okay.
The same on both sides of the y-axis.
Because the name does sound like something.
Okay. Even functions are, Jack's words were same on both sides of the y-axis, so symmetric across the y-axis.
Oh, and odd or symmetric across the
Odd or symmetric across the origin. So we have two ways to talk about even and odd. We can talk about looking at them graphically, and we can also talk about like f of x, f of negative x, and negative f of x. So, okay, so yeah, we're kind of reviewing the calculus twist on it today, those kind of things. So, even function. If you look up at the reminders/definitions here, an even function is a function that for all values of f of x, or of x, f of x and f of negative x are equal. So right there, that is the algebra version. That if you're trying to figure out if two functions are even, you want to find out if f of x and f of negative x are equal. Now, it also says this also means that the graph of f of x is symmetric about the y-axis. So that's the graphical version. My opinion is it's good to be familiar with both. Okay, it's good to be familiar that an even function is symmetric across the y-axis, so same on both sides, or that f of x equals f of negative x. So that's even. Odd, what do we remember here? So odd, f of negative x equals negative f of x. So it's one of those things, if it doesn't fall into the even category, we then find negative f of x and see if that's the same as what you found f of negative x to be. That's the algebraic way. Graphically, you need to realize that they are symmetric across the origin. So it's kind of a diagonal symmetric. When we physically look at something, the easiest way I can see it is if you take something and you flip it across both axes. So if you flip it across the x-axis and then across the y-axis, those diagonal quadrants that don't match. So that's symmetric across the origin. Okay? So, let's look at example 1. Is the function f of x equals x to the fourth plus x squared minus 6 an even function, odd function, or neither? Okay. We can start by finding f of negative x. So if we do f of negative x, that means we put every place we see an x, we replace it with negative x. So instead of x to the fourth, it's negative x to the fourth. Plus, instead of x to the second, negative x to the second, minus 6. Clean that up. And what do you know about negative x to the fourth? It's going to become positive again, right? Because a negative raised to the fourth is positive. What do you know about negative x to the second? It's positive, because a negative raised to the even is positive. And then minus 6. What did we just discover? F of negative x is equal to f of x. And when f of x is equal to f of negative x, we know that they are even. Could we, is it coming back? You've done this. And I say you've done this because I've taught it to you. It's not, okay, what do you remember from Algebra 1 or GEOmetry? No, I taught it in pre-cal. So, I'm not saying you remember it, but I know it's in there somewhere. It's possible. I don't remember, honestly. Yeah. I'm not going to say we didn't. I don't know. I know we definitely talk about it in pre-cal. Okay. Algebra. I'm happy we talked algebra. I would have made us talk algebra anyways. Could you have graphed it and looked at it that way? Does this verify that it is even? Yes, because that fourth power graph definitely looks symmetric across the y-axis, right? So, again, there are times it's advantageous to graph. There are times it's advantageous to think algebra. So, I'm just trying to point both out to you. Questions on that one? Okay. Example 2 is f of x equals x to the third minus x, an even function, odd function, or neither. Okay, let's start with f of negative x and see what we come up with. F of negative x, so I'm putting in negative x. It's negative x raised to the third minus negative x. What is negative x to the third? Okay, because it's an odd function, negative x to the third. Minus negative x makes it plus x. What have I determined right now? Okay, I know that this is not even because f of x and f of negative x are not equal. Okay, now what do I try? Okay, we already know f of negative x, so we need to try negative f of x. Do you remember how negative f of x works? Yeah, multiply the entire function by a negative, or essentially a negative 1. So, when we do that, it becomes, basically change all your signs, right? Negative x to the third plus x. What did we just find out? Yeah. These are equal to each other, yes? And so what's that say? If odd. If f of negative x equals f of negative x equals negative f of x, then it is odd. If I graph this, and again, I'm not saying you have to verify graphically, but for me it's good connection. And I'm actually going to zoom that in a little bit so you can see it a little bit better. Does this make sense to say it's symmetric across the origin? Okay, and again, what I would say is if you take, say if we take that right side. If we take that right side and flip it across the x-axis, it's going to become upside down. And then if you take it and flip it over the y-axis, it lands smack dab on top of it, right? That's the best way I can describe symmetric across the origin. Okay, so good news is that verifies. Just not as obvious stuff, right? I don't know, it's a variety of stuff. Okay, example 3. Evaluate the following. The integral of x cubed minus x from negative 1.5 to positive 1.5. Shall we do some integration?
Is this an odd equation that has some below the x-axis?
Huh?
Is that why it has some below the x-axis? Because it's an odd equation.
Well, it is, I mean, there is part of the graph that is below the x-axis. Now, the thing is it asking me to find area? It's just asking me to evaluate the integral, yes?
Is that x cubed?
Uh-huh. It's the same function technically as the previous one, isn't it?
Yeah.
Yeah. As I say, it's the same function. So let's integrate it by hand. But then we're going to go back to the graph and look at the y's and make it make sense. Okay, so if we integrate this by hand, because it doesn't say find the area or anything, it just says evaluate the integral. So I want to know, what does this integral equal? Doesn't really matter what the graph looks like or anything. It's what does this integral equal? That's what it's asking. So what is the integral of x to the third? Okay? I was already writing 1/4 x to the 4th.
Oh, that's
Wade says x to the 4th over 4. It's the same thing.
I was like, oh no.
Different people are different. I don't care what you write. Minus, what's the integral of x? Wade's gonna, I was going to say, Wade would say x squared over 2. Carly's going to say 1/2 x squared. Same thing though, right? I don't care which you write.
Is just one of them more simplified than the other, or is it just
They're the same thing. I mean, it depends on the situation. You will often, like if we look at the definition, it shows us like x to the 4th over 4 and x squared over 2. But when we go, I don't always like that. It depends on the situation. Okay. Evaluating from negative 1.5 to positive 1.5. So, write this out with me. I'm going to argue that we don't need to pick up the calculator to do this here in a moment after we write it out. So it's, I wrote 1/4 x to the 4th, but when I put this, it's going to be better to say x to the 4th over 4 when I plug the numbers in. Okay, so the first number we're plugging in is, so if I write 1.5 to the 4th over 4, are you okay with that? Instead of writing 1/4 times 1.5 to the 4th, I wrote it as 1.5 to the 4th over 4. Minus, it's 1/2 x squared, so 1.5 to the 2nd divided by 2. Then what do? Minus, and we're going to plug in the other one. So now it's negative 1.5 to the 4th over 4 minus negative 1.5 to the 2nd over 2. The sign in the middle? Yes. Because it's always the upper boundary minus the lower boundary. That's fundamental theorem of calculus is what that is. Now, why am I going to say you don't need to pick up a calculator? Do you see the things canceling out? This is 1.5 to the 4th over 4. Over here, minus, what do you know about negative 1.5 to the 4th? That's going to be the same thing as a positive 1.5 to the 4th, isn't it? Over 4. So what's going to happen with those two? They're going to cancel. Here we have a negative 1.5 squared over 2 minus negative, and then it's a negative 1.5 squared, but that negative, when we square it, becomes a positive. So you really have a negative plus this fraction. What's going to happen? Yeah. So my answer is going to be 0. When we evaluate that integral, my answer is 0. Now, I want to show you the graph real quick. I'm going to kind of zoom in on why it's 0. And the idea is, do I have this on my graph? I probably do. If you look right here, here's the graph of it, yes? Zoomed in. It asked us to go from negative 1.5 to positive 1.5. So it's not just starting here at 1, it's over past 1. So if you look here, like it's 1.5 over there, negative 1.5 there. Officially, even though it didn't ask us to find area, that's what an integral does, right? An integral finds the area underneath the curve, or between the curve and the axis. So if you look at this, right here, that's between the curve and the axis, right? Right here, that's between the curve and the axis. If you don't compensate, if it's asking you to find area, you'd have to compensate. Since it didn't ask us to find area, what happens? Those will cancel. Now, you also have this little piece over here to the left, because that's between the curve and the axis. And then, but you also have that little piece over there that's between the curve and the axis. So all those pieces are symmetric. Thus the whole idea of symmetric across the origin. And so since they're symmetric, they're going to cancel out. Again, if we were being asked to find the area between the graph and the curve, or in the graph and the x-axis, then we would have to take into consideration, we'd have to break this into 4 pieces. Okay. Questions on that one? Next one then. Carly complained we were getting to the more difficult ones. However, look at example 4 now.
That was the
Okay. Is g of x even, odd, or neither? So?
We just had one like this. Wait, why would you that?
Just what they named it.
Okay.
We could say h of x. We could say k of x. We could say m of x. Yep. Okay, so if we want to know if this is even, odd, or neither, what are we doing?
We gotta do the negative for the g of negative x.
Okay, let's do g of negative x, which is negative x to the third minus negative x minus 4. Negative x to the third is negative x to the third minus negative x plus x minus 4. What do I know at this moment? Okay. I don't know what it is, but it's not even because it doesn't match. Now we should find negative g of x. To find negative g of x, you're multiplying the entire function by a negative. So when you multiply that entire function by a negative, negative x to the third plus x plus 4. What do I know? It doesn't match. Oh, so close. But it doesn't match. So, what's my algebra tell me? It's neither.
I have a question.
Uh-huh.
So for the g of negative x one, you're only multiplying the negative by the x values.
Right. You're replacing that positive x with a negative x.
So you're not changing any of the original minuses, like in the actual thing, unless it's for the x.
Yeah. Notice, because like here, I plugged in the negative x, right? I didn't change this minus sign here. That minus sign stayed. But then in my next, when I started simplifying, oh, it's minus a negative. Minus a negative is a plus. Over here, I didn't change the sign out front. I plugged in negative. A negative raised to the third power is going to result in a negative.
But then on the second one, it's everything.
On the second one, it's negative g of x. So that means you multiply the entire function by a negative. So all you do is you just go through and change every sign. Okay. If I graph this one that we just said was neither, you want the visual confirmation? This took our previous graph and moved it down 4. Because it moved it down 4, we lost our symmetricness. It was never symmetric across the y-axis, and now since it's moved down, it's no longer symmetric across the origin. Okay? I'm not going to draw that. Example 5 is y equals negative 3 tangent of 2 pi x and even, odd, or neither. Ready to try it? Okay. Let's talk algebra. First time, make it negative x. So negative 3 tangent of 2 pi times negative x. As I clean this up, it's negative 3 tangent, and inside there, 2 times pi times negative x is, I'm going to say negative 2 pi x. Well, okay. When we have a negative in on the variable, on a trig function, we had a set of rules, or a set of identities.
Do you have to make it one over?
Back in pre-cal, we had a set of identities. That tangent of negative x is either equal to a positive or a negative tangent. Okay, we had it with all of them. We had sine, we had cosine, we had tangent, and then officially we had the others too. Okay.
I still have that.
Yeah, if you have it was on our list of identities from pre-cal. Yep, it's on there. It's actually called your even odd identities. It would be, I don't know, is it back here around lesson 5 or so?
This is chapter 5.
Okay. Happens to be chapter 5. So let's see. It's got to be here somewhere. Or on the line, and it's not. Ah, here we go. Okay, so back in pre-cal is our even odd identities. Here, it's listed as helpful identities. So this is right before lesson 5 in your calc notes. And in my calc notes, when you have a negative variable, that determines what it's equal to. You don't just get to put that negative out front and say, oh, it's negative of this. It depends whether it's an even or odd function. So if it's cosine of negative x, you take that negative off the x, and it's just a positive cosine. Okay, and that's because it's an even function, I'll be honest. Sine and tangent, notice when you take that negative off the x, that makes it a negative function. Those are good identities you just know. And so what I'm going to write right here is that tangent of negative x equals negative tangent x. Just given rule there. So, if this is negative 2 pi x, what does that mean? Take that negative out front, and that negative out front times the already negative out there is going to make a positive. So this becomes 3 tangent 2 pi x. Are we okay with that? Now, so what's that tell me right now? It's not even, because my sign didn't end up matching. Try the other one. The other one is where we take a negative and multiply it by the function. So it's the negative of negative 3 tan of 2 pi x. Well, what do you get when you multiply the negative of negative 3 tan? Positive 3 tan of 2 pi x. What do you notice? These are odd. Okay. They are the same. This is odd. Now, honestly, I pretty much could have told you this at the beginning. Sine and tangent functions are odd. Cosine is even. Okay? So, and we use those identities to help us there, but okay. And again, I guess I could graph that to show it to you. But okay, A or 6A, even, odd, or neither. What do you got? F of negative x is e to the negative x. Do I need to continue?
Yes.
Yeah, because it's not even. So negative f of negative x. No. Negative f of x. Sorry. Is what? Negative e to the x. What do we know on this one? Neither. Okay. B. F of x is e to the negative x squared, so f of negative x. That means I'm putting negative x in place of x. So it's already the negative of x squared. So it's going to be the negative of negative x quantity squared. What is negative x quantity squared?
Just negative.
Yeah, because efficiently we square the negative x, that becomes positive x squared, right? And then what do we already have out there? A negative. So this becomes negative x e to the negative x squared, which means it is the same, so even. And again, check these out on the calculator if you feel the need. That can help you there. Okay. One last one. Okay. G of x, even, odd, or neither. Final time. What am I doing? Okay. Let's figure out g of negative x to begin with. So it's negative x, quantity squared, plus cosine of negative x over sine of negative x. Let's get the easy part out of the way. What is negative x raised to the second? Positive x to the second. Now, what about cosine of negative x? What is cosine of negative x equal to? Cosine x, and how do we know that? Yeah, that identity I just showed you, it said cosine of negative x is equal to cosine x. So cosine of negative x is just going to become cosine x. What about in the denominator? What about sine of negative x? Yeah, sine of negative x is negative sine x according to the identities. So this is negative sine x. And so at this point, are they even? No. Oh, so close. So we've got an extra negative sign in there. Okay. Odd. We need to find negative g of x, which negative g of x means we're going to, I'm going to put a negative out front of the fraction, multiply the whole fraction by a negative. X squared plus cosine x over sine x. I chose to write like that the first time. How do we multiply a fraction by a negative?
Do the top or the bottom.
Okay, so to multiply a fraction by a negative, you either multiply the entire numerator by the negative or multiply the entire denominator by the negative. What do you notice then? If you multiply that negative into the denominator, is it going to match up? I've got a negative, my x squared plus cosine x is the same. If I take that negative and multiply it to the sine x, then that matches up over here. Or I could take this negative that's on my denominator and factor it out over here. So these two here actually do match up. There's a couple different ways you could write it, if you wanted to show that, but they do match up. And so since they do match up, this is an odd example. And if you're hesitant, you know what? Check that graph. X squared plus cosine x divided by sine x. Except before I graph that, I need to switch to radians because we've been in degrees in pre-cal. Now I should have gone for a radian one. There we go. Wow, my calculator is slow motion. Okay. It's still working, but that's all we're going to be able to see. Does that make sense that we said odd? Yeah, we could flip that upside down across and it would match up. Okay?
I like this lesson.
Okay, it was essentially a review lesson. There really are no calc standards to go with what we taught today. However, it is helpful to be able, there are times within calc lessons that we refer to even and odd. And so it's rare that I teach a lesson at this point in the year that has no calc standards associated with it, but if I don't review this, it could get ugly. So,
I don't think we've had a lesson this easy since the first lesson.